Hello everyone. In today's video we are going to talk about these magic numbers. Okay, why they are magical, let us see. For example, if we go with the first example, 371 is the number. How many digits are there? This is a 3-digit number. There are 3 digits, right? So what I am doing is I am writing the digits 371 and the power is 3 because this is a 3-digit number. Okay, so surprisingly and magically 3 to the power 3 cubes plus 7 cube plus 1 cube is just 371. Similarly for this number 1 to the power 4 plus 6 to the power 4 plus 3 to the power 4 plus 4 to the power 4 is actually 1634. Just these digits 1634. Similarly here these are the digits 5 4 7 4 8 and to the power 5 gives you a 5-digit number given by just this basis 5 4 7 4 8. Okay, this is magical and this is surprising. There is no way to deny that. Anyway, so the question is how many such numbers can be found out. Okay, so how many such numbers are there? Okay, that is the basic question. Interestingly, we have seen in number theory or other things like some interesting families are infinite. Okay, but here the interesting part is that such numbers cannot be cannot be infinitely many. So there are only finitely many. That is what it makes them interesting. Okay, we'll see why and how, and these numbers have some special name. Okay, we'll also see that, but before we further going to those proofs and other things, we'll see more examples. Like here 3-digit number 153 370 371 407, all for all these, if you just cube the digits, okay, every digit, and add them, you will get the number back. That is the magic here. And similarly 4-digit numbers are these, 5-digit numbers these, and for all of them you can actually check the same magic like this happens. Okay, fine, but the question is how many such numbers are possible. Okay, yeah, so they have a name. Okay, these are called narcissistic numbers. Okay, and the claim is there are only finitely many such numbers. There can be only finitely many. That is the interesting part. Why, we'll see. But before that, we see this n equal to, suppose this number d1 d2 d3 and dn, which means what? This is not product. Okay, this d1 is the first digit, d2 is the second digit, d3 is the third digit, and dn is the nth digit. So basically how many digits are there? Small n. Okay, so this is a small n number of digit, and n is the actual numerical number, right? For example, we started with 371, right? Yeah, so n is the number and there are n digits. What are the digits? d1 d2 d3 dot dot dn. Fine. Okay, suppose this number is narcissistic, then what happens? So from the condition, if you remember, we have this. So the numerical value here, the number n must be equal to d1 to the power n plus d2 to the power n plus d3 to the power n plus dn to the power n. So d1 d2 d3 and dn, they are the digits of the number, and power is n because this is an n digit number. Fine, yeah, so this is the condition. Okay, so now what is the maximum value of this right hand side? If I ask what is the maximum value of this right hand side, okay, the answer is very simple. Okay, the maximum value is simply this, because each of the digit can have maximum value 9. So if we put 9 for all of them, that is the maximum possible number. So what this gives is just 9 to the power n into n, because there are n digits, n many numbers, right? d1 d2 dn. Fine, so this is the maximum value which this right hand side can take for any number, right? Because we have put d equal to 9. Similarly, okay, so what is the minimum number with n digits? So n is, this capital N is an n digit number, right? Small n digit number. So what is the minimum value? If I ask what is the minimum number with 10 or 3 digits, okay, then it is just 100, right? If I ask what is the minimum number having 4 digits, okay, then it is 1000, which means the minimum number with n digits is actually 10 to the power n minus 1. Fine, this is also absolutely fine. So this is the condition for a number to be narcissistic, and then minimum numbers with n digits, which is capital N here, is 10 to the power n minus 1. And on the right side you have this. What is the maximum value of RHS? We have seen that it is 9 to the power n times n. Okay, well done. So now one fact is that this 10 to the power 9 minus 1 is actually bigger than 9 to the power n into n. For all n, no. For large n. So basically when n is large enough, then you have 10 to the n minus 1 bigger than 9 to the n into n. So basically the maximum value of right hand side cannot even reach the minimum number, which is minimum number of n digits, which is 10 to the power n minus 1. Okay, that's why it fails. But we'll say how large this 8 can be and so on. Fine. Okay, so this can be proved. Actually, we don't know why this is true, right? This can be proved by using just or by just noting down this simple limit. Okay, one can actually check that limit n going to infinity 10 to the power n minus 1 by 9 to the power n into n. This is the here we are writing this in the denominator. This limit is actually infinity. If you don't want to calculate, we can use graph also to check that this is the limit. Fine. How is that? Okay, so here we are on Desmos platform and I have written this function 10 to the power x minus 1 by 9 to the power x into x. Okay, instead of n I am writing x here because if I write n, the Desmos will not understand what it is. Okay, so for function we have to write in terms of x. Okay, so x is the variable here. Now if you see the graph of this function, okay, graph of this function is this. Okay, if you just zoom out, you will see something nice here. You see, after some value here, after 50, maybe 60 here, it is constantly increasing, right? Which means what? This again proves nothing but if x goes to positive infinity, this limit of this 10 to the power x minus 1 by 9 to the x into x, these values will blow up, which means the limit is going to infinity. Now instead of x in the limit we had n. That is not a problem. This is just a symbol. Okay, so this means what we have, limit this is infinity, and from there we can actually write 10 to the power n minus 1 by 9 to the power n into n is actually bigger than 1 for some n value. Okay, which n value we can also see it from here. Let us check how to do it. So basically here if you see, let me zoom in a bit more. Okay, I think here. So now you see that the scaling here is 60, 60, 61, 62. So basically this is 1 unit. Therefore these squares are 1 cross 1, right? Fine. So now, so basically then this height is 1, this height of the square is 1, fine. So here at 62 you can see that this ratio is already leaving the height 1, which means it is bigger than 1, right? If you check here, it will be like at 62 it is 1.108. Okay, so for x equal to or for n equal to 62, that quotient is actually bigger than 1. Okay, so we can write it here, right? So for all n bigger equal to 62, this quotient is always bigger than 1 because the graph is never coming back to height 1, right? It is always going up and up, right? Therefore, for all n bigger equal to 62, this is bigger than 1. So then what we have actually from here, this, right? This is equivalent to this. So 10 to the power n minus 1 is bigger than 9 to the power n into n for all n bigger equal to 62, as we have seen in the graph, right? But what does this mean? On the left side here, we have minimum number with n digits, right? And on the right, what we have is this maximum value of d1 to the power n plus d1 to the power n and so on, right? Yeah. So now we see that for example, if we take even n equal to 62, then this amount 9 to the power n into n, this can never reach even the minimum number with n digits, right? Okay, so this is the number for an n digit. So basically nth power and then sum. This maximum value of this is never reaching even the minimum number with n digits, which means what? Which means that a number with 62 or more digits cannot be narcissistic. Okay, so till n equal to 61 we can have, possibly can have, we cannot assure now, okay, but possibly we can have narcissist number only up to 61 digits. And since this is 61 is a finite number, at finite stage, till that 61 stage, we can have only finitely many numbers and therefore only finitely many narcissist number, right? So it's clear that after n equal to 62, there is no such narcissistic number and there are only finitely many. This list cannot be infinite, right? Yeah. So that's all in this video, and if you find this video interesting, do press the like button and subscribe our channel to motivate us. I sincerely thank you for watching this video.